Good morning to all. I am Geeta, Assistant Professor from ECE Department, Rogini College of Engineering and Technology. Now I am going to handle the subject on Communication Engineering. So now here I am going to discuss about the topic on frequency division multiplexing. On completion of frequency division multiplexing, the students will be able to define frequency division multiplexing, draw the block diagram of FDM transmitter, draw the block diagram of FDM receiver. So first, what is mean by FDM? So the FDM is a multiplexing technique in which the multiple separate information signal can be transmitted over a single communication channel by occupying the different frequency slot, so with a common channel bandwidth. So the FDM is basically used for mixing of analog signals. So we are having the multiple signal. This will be transmitted over a communication channel. So the single modulation, this will be achieved with a different carrier frequencies. So this is the single modulation with different carrier frequency. In frequency division multiplexing, the simultaneous transmission of the signal takes place over a common channel in which the channel bandwidth is divided into various sub-channels. These sub-channels comprised of different frequency slot over carrying individual signal during transmission. The transmission of various signals at a long distance through FDM technique. So the required bandwidth will be needed for the transmission will be too large. Now the question arises, so if we are providing the multiple signals, so the various frequency slot under the same channel bandwidth, so the above question, this will be based on the modulation. So the different input signal modulate the different carriers. This will be having the different frequencies. So these signals are mixed to form the hybrid signal for transmitting over a single channel. So next we are going to see the spectrum of FDM signal. This is the spectrum of FDM signal. So here we are having the frequency, and the particular frequency will be allotted to the particular channel. When we talk about the common communication channel, so we think that first comes to our mind is the overlapping of signals. So the signal will be overlapped to the particular another signals. So here the total available bandwidth is divided into various non-overlapping frequency band, so which will be carry different input signals. So this will be mainly prevent the interference of the spectrum of FDM signals. So the particular time slot will be allotted to the transmission, so only need the division of frequency. Sometimes the transmission during the same time interval, this will be leads to crosstalk. So in the FDM transmitter section, the frequency division multiplexer, this will be mainly used for the numerous signals that are transmitted along a common channel. This will be modulate the different carriers in the modulating signals. So here we are having the multiple signals. This will be used with a different carrier frequency. So the modulating signals and the modulated signals, this will be fed to the linear mixer, which a different form of normal mixer. So the linear mixer is simply produces the algebraic sum of the generated modulated signals. So the combined signal at the output of the mixer is then transmitted along the single channel. So this is the block diagram for the FDM transmitter. Here we are having the different signals, and this will be connected to the different modulators and the carrier signals. These modulators are finally connected to the linear mixer. Finally we will get the communication channel, then we will produce the composite signals. Then FDM receiver. So in the receiver section, the composite signal that is transmitted by the linear mixer over the channel. So the composite signal are feed into the different filters. This will be mainly bandpass filter. So each of the filters will be having the frequency. This will be corresponding to the carrier frequency. So the figure shows the FDM receiver, which receives the frequency modulator signals. So the bandpass filter passes the channel information without any distortions. The bandpass filter, this will be reject the all frequency and accept the signal of the desired center frequency. Further, the signal after being proposed by a bandpass filter, this will be goes to individual demodulator sections where the demodulation process will be takes place. So the signals will be placed to separate the modulating signal from the carrier signal. So after the demodulation process, here we are having the separate signals. So this will be actually transmitted over the same channel. So this is the block diagram for the FDM receiver. First we are having the communication channel. So we have to take the composite signal. This will be given to the different bandpass filter and this will be connected to the demodulator, different demodulators. Then finally we will get the separate signals. So in the bandpass filter and the demodulator circuits, so center we are having the individual channels. This will be selected by bandpass filter. So here we are having some advantages for the FDM. So it is a synchronization free technique as we do not need synchronization between the transmitter and the receiver. So it facilitates the transmission of a large number of signals simultaneously. So the FDM demodulation process, this will be very easy. So here we are having some disadvantages. The channel bandwidth is required is large, so it can result in crosstalk as several signals are transmitted during the same time interval. So it can cause intermodulation and frequency division multiplexing is to prevent the interference. This will be caused during the FDM. Thank you. We have to use the